So welcome. Thank you so much for joining me today after a really long day in your classroom. My name is Melanie Harding. I'm the K-3 math coordinator here in the Office of K-3 Education in the Division of Early Childhood Services. I was a teacher for many years. I started in preschool and then third grade and kindergarten. I was a math coach for the early learning grades and a supervisor. And I've been at the department now for a year, and I'm really happy to get to work with teachers from all over the state. Um, my director is also here, Dottie Speck. She is the director at the Office of K-3 Education.
Hi, everyone. Welcome. So glad to have you.
And, unfortunately, we're supposed to have a really large group, which, can be difficult, but, I know how hard it is for teachers after school. It is a really long day and there's a lot to do. So I'm happy to have you guys here. Thanks for coming. Okay, so problem solving in K-3 mathematics. Um, so I will just really quickly tell you a personal story. Recently, my current car lease ended and I had to make a decision. Usually I just turn in my old car and I lease another one, but this year, as you know, is very different. We're in the midst of this shortage of new cars and the new car prices are way up. So it's really not the best time to buy or lease a new car. But at the same time, used car prices are surging. So many used cars are selling at close to their original price. So I jumped on the internet, I researched the situation, did a lot of problem solving, and I found out that I could purchase my car, at least send and maybe turn around later and sell it at a higher price. But then I would be without a car. So I really had to decide what to do. I decided to purchase my car at least end and hold on to it until new car prices do come back down. Hopefully getting a good trade-in value on my current car. Of course, all this sounds great in theory and seems to be the right decision based on the data I have right now, but who knows if I made the right decision until sometime next year. This is really what problem solving is. It's not a word problem. It's real problem solving, real life. It's an adult problem, but it is a problem solving scenario where you do have to really put a lot of strategy and thought um, and research into it. So if you read the slide that's on the screen, I want you to think about this process. George Polya, who's often called the father of problem solving, wrote this book called How to Solve It. That was back in 1945. What he talks about, understanding, planning, solving, checking, these are the 4 steps of what I did basically to solve my car problem. And it's something that we can use many, many times throughout our instruction and our own life. So today we're going to just delve into how we teach our students to become problem solvers. We only have an hour. We could talk about this all day. If I research this, it just goes on and on and on. There's so much information. But today we are just going to try and hit on standards very briefly, problem types and schema-based instruction, sense making, not tricks, some tools and resources and tasks that you can use, and hopefully we'll have time for questions and comments. We will have time. I'm going to talk fast. Okay. So standards regarding problem solving actually begin as early as birth. We have our birth through third grade standards, and there is a cognitive section and a math section, and it talks about how we use our cognitive abilities as a toddler or even as an infant to solve problems. We bang our spoon on our tray to get our caretaker's attention, which is solving a problem, of course. And I won't go through all the standards with you, but in preschool, we do start to represent those word problems using data and pictures. Data and pictures and drawings. In kindergarten, we're adding and subtracting within 10. Again, objects, drawings, pictures, acting it out. In first grade, we're within 20, adding and subtracting with two numbers and 3 numbers. And in second grade, we're up to 100 using addition and subtraction, solving 1 and 2-step word problems. And third grade, 2-step word problems using all 4 operations. So you really do see a nice progression there in the standards. And again, it starts as early as birth. So if you could just read that slide, we're going to talk a little bit about schema-based instruction today. Again, there was a book by Carpenter called Cognitively Guided Instruction. It's all about schema-based instruction, and it's phenomenal, and there's so much research behind it. So again, this could be a whole day, but I just wanted to kind of make sure that everyone, was aware of it. And if you wanted to go out and get more information, you can. We'll definitely have more talks about it. But schema-based instruction really is just a word problem-solving strategy that teaches students to identify problem types by focusing on the underlying structure of the math situation. There are problem types. Within the appendices in the standard, there are tables that show those problem types. There's 4 different classes of problems. So this first table is all addition and subtraction. What I did here by highlighting it, it really is not, these are not just kindergarten problems. These blue problems are not just first grade problems, and these difficult subtypes might not be difficult for everybody, and they're not just second grade or third grade problems, but I did want to kind of separate it out for you a little bit. So as a teacher, by the end of kindergarten, if my children don't know how to solve these problem types in yellow, we're really kind of behind the 8 ball, and we really do need to move along that trajectory a little bit more. But again, that's not hard and fast. Some of these are done in preschool, depending on the child's developmental level. But as you can see, there's 4 types. I hope you can see my cursor, but there's the join problems up here, the separate problems, the part whole problems, and the compare problems. These join and separate problems involve an action. So in join problems, elements are added to a set, like in 1 through 3. And again, in the standards, they're not numbered. I just tried to make it easier for us for this presentation. So like 2 bunnies sat on the grass, 3 more bunnies hopped there. How many are in the grass now? Just joining a set that's already there to create that subset. In separate problems, elements are removed, like in 4 through 6. 5 apples were on the table. I ate 2. How many are on the table now? Now, the part whole problems down here and the compare problems, they don't involve action. In part whole problems, there's a relationship between the set and the 2 subsets, like in number 7 through 9. So there's 3 red apples, there's 2 green apples. How many are on the table? 5 are on the table, 3 are red, the rest are green. How many are green? So there's 3 there's a part whole, but there's no actual action happening there. And then the take apart situations can also be used. They're really great for showing the decompositions of a given number, which is another, really important standard in K and 1. And those associated equations, which have the total on the left of the equal sign, help children to understand that that equal sign doesn't always mean this is the product of, it's, the same as, which I do love. And I think we need to use a lot more of that in the earlier grades. Um, and then these compare problems at the bottom involve comparing or working with 2 sets, like in 10 through 15. So Lucy has 2 apples, Julie has 5 apples. How many more apples does Julie have than Lucy? And I highlighted these in blue. They are considered more of that first grade problem, but it's something that's so simple to do with concrete materials in kindergarten and even preschool. So please know that this is not hard and fast. It's really just to kind of give you an idea of the more difficult subsets and where you really should be starting with your kindergartners and where you should be getting them to. Same thing for grade. This is really grades 2 and 3. I would say 2 through 5. It's more about multiplication and division. The language in these array examples shows the easiest form of an array problem, like 3 bags with 6 plums in each bag. How many plums are there in all? The harder form is to use the terms rows and columns. Like the apples in the grocery store window are in 3 rows and 6 columns. How many apples are in there? Both forms are really valuable. Area involves arrays of squares that have been pushed together, so there's no gaps or overlaps. And those array problems include really important measurement situations. Really, those first examples in each cell describe or examples of discrete things that children can really draw, count, move around if they want to act it out, use manipulatives. They're a little bit easier um, to start with, but they should be given as well as the measurement examples, but maybe before. I'm just going to go through a few examples with you, and then we're going to move on. I really want to show you how you can use some manipulatives and tools to solve a lot of these problems. The join problems, they start with result unknown, which is, again, we do these all the time. I just talked to a first grade teacher who said she spends so much time on addition and addition word problems. By the time she really did present those more difficult subsets, it just, her kids, all they wanted to do was take two numbers and add them together. So she really wished that she had started earlier with result unknown, change unknown, and start unknown all at the beginning of the year. So Robin has 6 toy cars. Her friend gave her 8 more. How many does she have? Change unknown is that missing add-in. Robin has 6 toy cars. Her friend gave her some more. Now she has 14. How many did her friend give her? And Robin had some toy cars. Her friend gave her 8 more for her birthday. Then she had 14. How many did she have before her birthday? Separate problem, same thing. Result unknown is the typical problem that we all give with the equal sign and the answer. Tanya has 13 pencils. She gave 4 to Wayne. How many does she have left? Change unknown, Tanya had 13 pencils. She gave some to Wayne, then she had 9 left. How many did she give to Wayne? And now start unknown, even more difficult. Tanya had some pencils. She gave 4 to Wayne, and then she had 9 left. How many did she start with? So we have to make sure that when we're doing those add to and take from problems, we're doing result unknown, change unknown, and start unknown, all of those subsets. It's really important. Um, and then the part whole problem, same situation. The whole unknown, a little bit easier. 8 boys, 7 girls playing soccer. How many kids are playing soccer? But the part unknown, there's 15 kids playing soccer. 8 are boys, the rest are girls. How many girls were playing soccer? Both add-ins unknown. 15 kids are playing soccer. Some are boys, some are girls. What do you think? How many are boys? How many are girls? Starting to really decompose different types of numbers. And the last type of problem, compare problems. Again, these aren't the more difficult problems. They're just not presented as often. Joy has 8 books. And I should just stop that before I go into it. They compare 2 distinct sets. Like I said, there's a relationship between the quantities, but there's no action necessarily, because you might join, I might separate. There's a reference set. So if you look here, Joy has 8 books. That's our reference set. A compared set, Greg has 12 books. And then a difference. How many more does Greg have than Joy? Now the compared set is unknown. Joy has 8 books. Greg has 4 more than Joy. How many books does Greg have? And then the referent unknown, Greg has 12 books. He has 4 more than Joy. How many does Joy have? And I'm going to show you how we can use some manipulatives to solve this. Um, Before we go on to that, the wording does matter. Children's ability to solve word problems really depends on whether they can understand it or not. A lot of people say, oh, well, my children can't read at a 3rd grade level, and how can I present these problems? Well, read them to them and make sure that the wording isn't so confusing. We all remember the train left the station at, you don't want these types of problems that are so difficult for children to grasp. They're not relevant, and they're kind of written in a way that the order is not, it's not sequential. So maybe have it more correspond to action sequence. So Jen just ate 3 cookies. She started with 9 cookies. How many does Jen have now? It's not sequential and it is confusing. But if you say Jen has 9 cookies, she ate 3 of them. How many does she have left? It's more sequential and understandable. Also, reword problems, when you're doing those compare problems, there's 5 birds and 3 worms. How many more birds are there than worms? It's hard. But if you say there's 5 birds and 3 worms, how many birds won't get a worm? Kids can already visualize that and start to draw that and make sense of that in their head. Um, One other thing I'll say about this is that I said sometimes I might subtract and you might add. We need to make sure that we're allowing children flexibility. to solve the way that they are comfortable with, um, and rely on their strategies and also be able to share their strategies. So make sure that you're not saying like this is an add to problem. So we need to only add. Well, they might think subtraction when doing an add to problem, and that's okay. All right, so this is just kind of um, a summary of what we talked about. So if you want to just read that to yourself. What I will say is that when we understand these types of word problems and that there is a hierarchy and a difficulty, we can reflect about students and how they're thinking about problems, and we can have some really good discussions with our peers in PLCs. Um, this is something I'm not even sharing this with you guys for any reason other than when I was in the kindergarten classroom, I did use. Let me just see if I can get to it another way. Hold on. Oh, goodness. Oh, there it is. Um, I did take the 4 kindergarten subtypes and, I did create a little assessment for myself so I could make sure I took some notes on how are children solving these add to problems, results unknown within 5, within 10, just so I could start to take some notes and reflect on how children are doing. And then bringing that together with your PLC is so valuable, um, to have that formative data as you go. Again, that's just something I created in my own classroom, but it's definitely something you can create for yourself. All right, we're gonna switch gears and move into some standards for mathematical practice. The first standard for mathematical practice is make sense of problems and persevere in solving them. Students who make sense of problems should be able to explain the meaning of a problem, plan that solution pathway, and ask themselves, is this reasonable? Does it make sense? Um, and that's something that we do sometimes miss, and we're going to talk a little bit about that. Keywords. This is a big problem. And when you think about reasonableness of a problem and SMP1, and using that sense making, it really takes a lot of the sense making away from children. Um, when I was in the classroom, my first year in a third grade classroom, I had my keywords poster up and I thought it was the right thing to do. And as we went along, my students said, well, wait a minute, in all could be multiplication, um, not just addition. So then we started sticking these sentence strips all over my poster. And by the spring, I was like, I'm done with the keywords poster. But I didn't know that it was confusing more than helping my children. I did the best I could do until I knew better. Now that I know better, I do better. But I'm just quoting Maya Angelou. But for the most part, this is how I was taught. And I thought it really helped, but it doesn't. Can be very, very confusing. Well-intentioned teachers have tried to turn this process of problem solving, which is really messy sometimes, into rules or algorithms. And this is why we see students boxing numbers and underlining questions and looking for keywords. All of these shortcuts just give children permission to not read and not understand. And if they are struggling with reading a word problem, read it to them and have them use oral comprehension to understand, reword, summarize, visualize the problem. So keyword strategies are just ineffective in dealing with anything but a really narrow set of problem situations. That's another thing I found. When I have a problem like there's 12 tiles per box and I bought 4 boxes of tiles, how many do I have altogether? If my kids are looking for that altogether, they're going to add it. And by the way, they like to add. It's nice and easy. Tanya has some pencils. She gave 4 pencils to Wayne. Then she had 9 left. How many does she have to start with? I don't know. I mean, left sometimes means subtraction, so maybe I should subtract. But again, if I'm not reading, understanding, thinking about the reasonableness of my answer, I could do that. Aiden has 28 fish. 15 are blue, the rest are yellow. How many are yellow? Well, I don't know what to do. There's no keywords there. So it really does confuse children. Um, I'm going to just give you, now this is an example of, I think, an older student. I think she's in 5th grade, but again, we are starting this at a very young level.
Here's a word problem. There are
Can you hear it? Just, okay. I didn't want to keep going.
295 students in the school. School buses hold 25 students. How many school buses are needed to fit all the students?
Okay. Yeah,
So how many school buses?
320.
And how'd you figure it out?
Well, when you read it to me, you figure out what is the number that tells you all the information, like if it's adding, subtracting, multiplying, or division. And since I heard all, I figured, oh, that's plussing. So I plus 295 and 25, and I got 320.
Okay.
Sorry you couldn't see the child in the video, but she was actually really proud of herself because the teacher didn't tell her that, hey, you're on the wrong track. And it's rough to see a 5th grader who seems to be a very articulate student use that strategy, and what happens. Standard for mathematical practice 2 asks students to reason abstractly and quantitatively, which we do starting, again, as toddlers in preschool. We can make sense of quantities, find the meanings of quantities, represent a solution through pictures, numbers, words, use real sense making. I'm just going to show you a similar video, but a different outcome.
Here's a word problem. There are 295 students in the school. School buses hold 25 students. How many school buses are needed to fit all of the students?
12.
12. And how did you figure that out?
Because 11 equals 25 times 11 equals 275, and plus another 25, so all of them can fit, and there's going to be 5 seats with a remainder. It'll have extra space.
Okay.
Did you hear how she made sense of the remainder? I just loved that. She's really making sense of the quantities where that other child was like 320 buses. There's just no sense making and representation of the actual real quantity. She didn't represent it through any pictures, numbers, or words. She was really using a lot of mental math. But I thought the sense making there was just great. So those are some of the alternatives to sense making. Using to keywords is using sense making. So Mrs. Harding has 3 children. They each have a box of chicken nuggets. Each box has 6 nuggets. How many nuggets are there in all? Again, you hear in all, you can add that 6 and 3 right away, making that mistake. But students can draw it out, tally marks. Maybe they can abstractly start to add. Maybe they can start to create some arrays, but it needs to be understandable, concrete. It needs to make sense to them. Standard for Mathematical 3 also talks about, Mathematical Practice 3 talks about constructing viable arguments, critiquing the reasoning of others. I don't think I'm going to show you both videos, but I'll show you this. Before I even show you, well, I'll show you.
Look there, you need 2 hours and 15, 25, 35, 45, and that's 30 minutes. Because 3 minus 2 would be 1, and 1 plus 2 would be 3. And then you know that it would be 2 hours and 30 minutes, and then it would be 3:45. Because
I just love her because she's not messing around. She is definitely justifying her answer. But teaching elapsed time in 3rd grade, I did struggle with that because developmentally kids weren't ready for it at the same time. It was really an abstract way of thinking, and you can't add time. You just can't really do that without messing up. So they use like those elapsed time number lines, but they did have to really, you know, discuss their thinking process aloud. I won't show you this whole video, but just so you have it as a resource, if you go to Inside Mathematics, for every standard for mathematical practice, they give you videos for all grade levels. And this happened to be a third grade video where these kids had the same exact problem and they had to solve it and really just talk it out and come up with the same answer.
Right now,
I'll
I
show
want
you
you
a
to get
little.
together and decide who's going to represent you. Some
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
What I will tell you is this
Three
girl was
bags,
wrong,
three
but
bags.
she was
Plus
really
12 equals 15.
justifying
1,
her
2, 3,
answer and they had to
4,
work
5,
it out.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But it has three bags. So these are the three bags. 1, 2, 3, and I'm counting by threes.
So after she explained it to her partner, she really had a lot of good thinking and a lot of good math. And that's why we always say, I believe the answer is really important, but the answer isn't, her answer was correct. Sometimes the answer is right. 7 plus 3 is, or like the chicken nuggets, 6 plus 3 is 9. That answer is correct, but it doesn't answer that question. So she was really justifying her answer and her partner had to kind of bring her back and say, you're right about the math, but we don't need to add it that many times. There's not that many bags. Let's read the problem again. So anyway, that's a great site to go to if you do want to share at PLCs some videos of these SMPs and what does it look like in your grade level. Okay, so Standard for Mathematical Practice 4, Model with Math. Honestly, this is so much more intense than what I wrote here on the screen. But just for our purposes, students do have to convert text and mathematical concepts into multiple forms of representation. They should use concrete representational models, symbols, drawings, pictures, tech tools to communicate their thinking. So I'm going to just use a rec and rec and go back to that problem. Those compare problems that were really hard, that difficult subtype. It said that Lucy had 3 fewer apples than Julie, and Julie had 5 apples. Well, Julie has 5 apples, and Lucy has 3 fewer. So how many does Lucy have? So much easier when using those concrete models to have children. And that's why I say these difficult subtypes, again, that's my terminology. It's not in the standards, but they are difficult for children. I taught them. They were hard. Those missing add-ins are hard without concrete materials. If you're talking about, there's 5 apples on the table. Let's put those apples on the table. I ate some of them, and now there's 3. Okay. So here's the 3. I ate some. Well, how many are some? So starting to use, again, rec and recs aren't the only way to show this, but I do love rec and recs in that they're very flexible. You do have 20 beads, so it's great for K and 1. Just one tool that you can use. This is more of a kindergarten problem or preschool. Lisa has 2 red marbles, 2 yellow marbles. How many does she have altogether? I'm just trying to focus on those concrete models, making sure that I'm using Unifix cubes or chips and counters. I don't even really have a pictorial model on here, but kids can use dot paints. They can just draw it themselves. Here's a 10 frame where maybe they drew it, maybe they're using those concrete materials. It starts to become a little bit more abstract when we use those part whole mats and number bonds. So it starts to bring us to those actual abstract number sentences. But we really do need to model with a lot of concrete and pictorial materials when solving problems. It shouldn't just be a quick turnaround. Here's another example for third grade, really. Tape diagrams are really powerful tools for learning math and just drawing it out. It's just like a segment of tape and it's used to illustrate number relationships. You can call it a strip diagram, bar model, fraction strip, length model, but it is a good tool to use. I'll just show you a quick video of it. I'm not going to show you the whole thing. But again, this presentation will be available for you guys.
Today I'm going to show you how to solve a multiplication or a division problem using a labeled tape diagram.
So she draws the tape diagrams just to show you what they look like.
Draw
Starts to
my
break down the problem.
tape going across, and for every section I separate that. Let's see. I have 2, 3, 4, 5, 6, 7, 8, 9, 10.
Let me go a little bit quicker. And they do want
Oranges.
them
They
to
let us
label the
know that
diagram so they start
if
to see that
the unknown
abstract
in
number
my
sentence
problem
coming into
was
view.
how many is in a group, how many oranges there are, instead of putting 2 oranges, I would put question mark oranges. At the bottom, I'm going to show how many there are altogether, and the problem tells us there are 12 oranges. And the other piece of information that I need to know is how many groups there are. If they told us how many groups there were, I would write that here. Since they don't, I'm going to write question mark.
So you can see how you can use it for, result unknown, change unknown, start unknown. It's both add-ins unknown, one add-in unknown. It really can be used for a lot of different problem types. But that's just one example. So I do want you to think about when we did the flexible small group instruction PD a while back, we talked about what our block would look like. And I really thought, I don't know how much time you all have for math, but 10% of your math block really should be engaging in some problem solving daily. Doesn't mean you can't do more. I definitely feel like it's great to use in small groups, but we should be engaging in it daily. You should include many different problem types, not just result, total, difference unknown. And you need to do those more difficult subtypes like bigger or smaller unknown. The problem of the day shouldn't be that daily answer getting. You know, those quick problems that we do every day, we have a little notebook or a packet of dittos. It really can't be those just answer getting type problems. We have to, you know, sometimes we should just give them the answer to delay that answer getting. And we're going to talk more about that. I'm just going to see the time. I'm just going to show you this quick video because it always inspires me.
Imagine the awesomest thing you can, like an automatic grilled cheese maker, or a time machine with an automatic grilled cheese maker. Now imagine who's going to invent it. Him? Glasses here? Whoever they are? Or maybe her? But how do kids like these become the types of people that do things like this? Maybe we should ask this guy.
Knowledge is heavy. Sometimes it's a limit to have new ideas. That's the problem with the old schooling, because they were teaching answers. I believe questions are probably more important today than the answers.
Erno's cube is a question waiting to be answered. And when the right person finds the right question, something amazing happens. They start seeing the world as it truly is. Not a place to be memorized, but a place to be figured out, flipped, turned, twisted, and ultimately made better forever. Today, she may be an octopus, but help kids like her fall in love with problem solving, and they will embark on journeys to become scientists, artists, engineers, designers, inventors, or something no one's ever been before, but you can bet we're gonna need. That's why moments like this, go, and this, and this, and especially this, are so important. Because there are companies to found, planets to walk on, time machines to invent, a future to be made amazing. We may not know what it's going to look like, but we know who's going to do it.
Okay. So getting back to that problem of the day, we need to make it fun. We have to start with clay, dot markers, puppets, toys, snacks. Students have to associate solving word problems with fun. Fun is a really great hook. Think about, I don't know how you felt when you were in the classroom, but sometimes when it was time to do problem solving, I wasn't really excited about it. We need to hook them with the fun, and it should be relevant. I know for my third graders, all we did was Pokemon problems or problems about them, because that's what they were interested in. There were no cornfields in the city that I taught in. We didn't use, farm problems. We used problems that, about McDonald's and the bodega down the street, and we lived by the beach. Um, I use kid watching to assess like their interests, customs, traditions. You have to keep them at the center and keep the language simple and understandable for the levels that you're teaching. Remember that wording matters. Also, strategies matter. Students need a lot of opportunity to share their strategies. What exactly are they doing with those numbers? Does it make sense? Are they using the math that they're learning? Because if you guys are doing doubles and doubles plus one, what good is that learning if it's not being transferred to the problem solving experiences? So while you're doing that strategy, start to do some problem solving around that. It's important to spend time talking about strategies and how one strategy may be more efficient than another, depending on the problem solver. Delay answer getting, we have to stop just giving them that word problem a day and having them solve it in a quick amount of time. Maybe focus on a problem of the week. Talking about perseverance, students need to persevere through problem solving. They have to be taught to stick with it, not give up. And that, I have to be honest, there's a lot of, you have to do mini lessons around perseverance. I used to have posters up in my classroom. My kids even liked the Sesame Street. We used to listen to this probably once a week, but these fun like videos, I'm just going to share a couple because they're fun. And third graders even love them, not just kindergarten.
When you get your next big idea, Grammarly's tone suggestions can help pitch it with confidence.
Wah. Oh, how does it go?
These no look right.
Oh, we'll never get this.
Oh, you missed the drum. No.
There. 2 plus 2. Oh, boy. Mama will never get it right.
You tried to add, but the numbers came out wrong. You tried to sing, but you didn't know the whole song. You tried to cook, but the food it didn't taste right. You tried to dunk, but you didn't get enough hype. You didn't do it right now, but keep trying. You learn how. You just didn't get it yet, but you'll get it soon, I bet. That's the power of the yes.
Just think about starting off your morning with like these fun videos while kids are just signing in and things like that.
Ooh.
It's very young Bruno Mars.
When you wanna do something that's new and it seems really, really hard to do, you feel like quitting, you feel you're through. Well, I have some advice for you. Don't give up. Keep on trying. You're gonna make it.
Okay. I only play these for you because I do think that they're really important, because I don't think that we think we shouldn't have to teach perseverance. Sometimes it is, oh my goodness, they don't have the grit. They don't, but we have to teach that grit and perseverance sometimes, or reinforce it anyway. And scaffolding matters. Use scaffolded templates to scaffold the problem solving process. So Polio laid out those 4 phases of problem solving in his book, How to Solve It. I mean, how many years ago in 1945? There's been templates modeled after that work for forever. This is one that I made. It's just understand, plan, solve, check. It's just an organizational tool that follows those simple steps. Sometimes we would do this for the full week. Step 1, we would just read it, understand it, discuss the situation, what's happening, visualize it, summarize it. Step 2 would be making a plan to solve it. Should I draw a picture, tally marks, build an array, make a table? Am I multiplying? Am I dividing? Am I adding? Am I doing both? Because it's 2 steps. Am I using my hundreds chart? All of those things that they need to think about to plan how to solve. And then on the third day or step 3, solve the problem. Put your plan into effect. Work with a partner. Clarify your answer. Justify. And then step 4 is where we check our answer. We reflect on it. Does it make sense? Because like I said before, 3 plus 4 is 7, but the problem really could have been 3 times 4. So we just need to make sure that it's reasonable. We're not talking about 320 buses, you know? This is just one for kindergarten where, you know, you could read it and build it and then draw it, or even build it, draw it, and then start to write the abstract number sentence there. Just another, you know, organizational tool. I'm going to show you one.
Miss Kavanaugh has some jelly beans here for us. All right, we have jelly beans. And you can use your jelly beans in the top box, okay, to try to come up with how to solve this problem. How can we solve this problem using the jelly beans? We're going to build the problem with our manipulatives. Do you think you can try it? I'm going to read it one more time, and then you can go right to work with your jelly beans in your top box. I had 7 jelly beans. My sister gave me 2 more.
Okay. So she's just using it in small group, and students start to solve.
That 2 are from someone else. Can we draw something to kind of show? Who has an idea? What can we draw? What can we draw to show?
We can make a box to cover 2 of them and a big box to cover the 7.
Can you show me what you mean? Go ahead, draw it.
Okay, so she's doing the same thing, but she actually goes down to the number sentence, which isn't always correct. Like she had the equal sign in the wrong place, but the teacher questioned her, well, what does that mean? That sign mean? It means the same as. So she did fix it. 3-act tasks are another really fun way to do problem solving every week. I just put a link up here to bring you to some tasks and what each act means. Really, the first act, you're just showing them a visual. Remember, problem solving needs to be, I always call them low floor, high ceiling problems. Everyone should be able to answer. The language needs to be understandable for everyone. Maybe there's a lot of visuals involved. I worked with a lot of multilingual learners, so that was always something that we kept in mind. So the first act is a visual. We're going to show that photo, that picture, pique their interest, and we're going to have them start to notice and wonder. So I'm going to just show you some kindergartners doing that.
How'd that happen?
Do you see the little heads? I mean, they're popping up all over the place. So it did pique their interest, and I'm sorry about this. And it was something that they can all think about, notice, wonder. And when they are noticing and wonder, you start to take down some of their ideas on chart paper. And it's whatever they're saying. Like sometimes, hold on.
You notice in the video, and then some things you might want to know. Some things that you want to You notice that they're floating, right? You notice that they pop.
That's what
What else do you notice about them?
That's not big. Oh, I heard like pop, 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 pop. I heard like the balloons that pop and they pop. Probably down 6. I heard like that was 9.
So they're already talking about numbers that they heard and what they're noticing. They were all engaged. And when I do take down their noticings and wonderings, I always want to make sure I respect what they're saying. One time we did one with a man grabbing cookies from a package, and he said his hand's really big, and I said all right, and I wrote it down. But I said that's important because a big hand can grab a lot more than a smaller hand. And they were excited because they were coming up with some really good ideas. So what happens is after they notice and wonder, we try and get them to come up with a question, and the teacher can guide them to that question. And that's the problem that we want to solve. Like rubric said, you want to come up with questions that need to be answered. So they determined they want to know how many balloons are left after all of those popped, and they weren't sure how many pops. They wanted to hear it again. And I showed them this. There was 1 green, 2 yellow, so on and so forth. And then they had to figure out how many balloons there were in all and then take that number, I think it was 7, away to see how many are going to be left. And then I gave them the big reveal at the end.
Find out how many there are in all and how many pops. So can you use your 10 frame to fill up?
Sorry, I wanted to go the other one. So they just used their 10 frame to use those colors. They filled it up, and then they started to take away.
You did it. How many did you take away? 7. Can you count them? Can you prove it?
1, 2, 3, 4, 5, 6, 7.
And how many are left?
3.
Right, okay. What about you guys? Did you take away 7? And how many are left on your 10s frame?
3.
You take.
Okay, and then you just give them the solution. And they usually get really excited because, by the way, they're usually right because they're really engaged in the work. Sometimes it's not a video; it might just be a picture in small group. We did this, and they showed them the picture of the M&Ms, piqued their interest. What do we notice? What do we wonder? They started to jot. I jot down what they say, and then they come up with what do we wonder? What question do we want to answer? And then I kind of push them to the question that I want them to answer. How many candies did they use? And students then work together to answer the question. But we determined that they might need some more information. I had to give them how many pink and how many green, and then we used a hundreds chart to start to do the 2-digit addition. Really fun stuff. Presenting real world tasks. You need them to sometimes give them these rich problems and just get out of the way. Let them act it out. With the best intentions, sometimes we give too much support. So this one was, we were having a party. We set up 4 chairs. The doorbell rings and there's 7 friends at the door. Do I have enough chairs? And they acted it out and then they drew it. And then they even got to the point where they were writing abstract number sentences. I just thought this was a funny cartoon that only in math problems can you buy 60 cantaloupes and no one asks you, what the heck is wrong with you? I don't understand. Why are you buying that many? I'll just show you one. But again, I'm going to share this. So if you want to go back, you sure can.
Problem today.
There was 7 friends at the door, but there were only 4 chairs.
Okay, 4 chairs. So how did you solve the problem, if you had enough chairs or not?
If I add 3 chairs, I'll have enough chairs for all of my friends.
Oh, how did you figure that out?
Because I did 4 plus 3.
Oh, so you counted up the friends? Oh, very good strategy. Did you write that down?
Mm-hmm.
Okay, why don't you add that? Write down what strategy you used to solve.
I did write.
Oh, you did? Oh, look at that. What does it say?
We need 3 more chairs because 4 plus 3 is 7.
So he was using his abstract. He really knows some number strategies. Whereas this student, he drew it out and he pointed to the chairs and showed how he figured it out, which was awesome too. The answer is another really great problem solving activity. I used to start my day with this where they would walk in and the answer was on the board and they had to figure it out. And sometimes you can really differentiate. And, some students I might say, I want you to use a fraction today. The answer is 12. Use a fraction in your problem. And it might be, 6 divided by a half is 12, whereas some other kids might be doing 6 times 2 is 12. Just depends on their level, and that's okay. But you can differentiate. Some kids may be doing something a little bit different. Estimysteries. I think I have this up already, but let me look. Estimysteries are just a really fun activity, and these go from pre-K up to, I think, 7th grade. And they're all just these PowerPoint presentations. And a lot of times they have scaffolds for the children. So they would sit with their partner and you would show them the visual. Again, low floor, high ceiling. Everyone can do these types of problems. How many eggs are in the pile? As the clues appear, we start to estimate and narrow our estimation. So the first clue, and they don't all have scaffolds, but if you go to the website Estimysteries, you'll find some that you like and then some that might not work for you, but there's thousands, I think. So the answer is part of this pattern, 1, 3, 5. So now they start to write down some estimates of what they think it could be. And they could work with a partner, and the partner could say, no, that can't be it. It might be it might not be it. But then the scaffolds come up. So now if they picked 14, they're going to have to change their answer, and that's okay. They keep narrow. You're not just one right answer from the beginning. You narrow it based on your clues. The answer has 2 digits, so now that scaffold's going to change on the bottom. All those 1-digit numbers go away. It doesn't include the digit 2 or 3. And the last clue, it doesn't include the digit 7. So now it's 11, 15, or 19. Let's see if you're right. Hopefully you guys were trying. And there's your answer. And a lot of times they have it on their dry erase board and they're very excited. And sometimes they don't. They change it real quick, and that's okay too. There's the 3 container ones, which are really fun. Again, these go up through higher grades. So you can do this in kindergarten through 3rd. So what's the total number? The total is 31. So you give them the total right away. So now the wheels start turning. Now I have to divide 31 into 3 cups. Is it even? I don't know. What do you think? Well, now I have 10. So how many are left? And now they start to think about that and they have to figure it out. Well, there's 21 left. So is it going to be maybe, 11 and 10? Is it going to be something different? 12 and 9. So again, this would take a lot longer. I'm just whipping through it with you guys. But these are just really fun thinking games, problem-solving games, just problem-solving activities that you can do with your kids on the daily. Numberless word problems are also great. Don't provide actual numbers sometimes. When students can think freely about what to do, it makes it a little bit easier. So Jeff has a pile of wood planks. He wants to use all the planks to build coops for his chickens. They're all going to be the same size. Again, I wouldn't use coops if I was teaching in the inner city. I might use something different, and that's okay. But they're going to talk about how Jeff can make those equal piles of planks. You might even give them craft sticks to do this. And what's going to happen with those leftovers? And what does the leftover mean? What does that number mean? So they're starting to really make sense of these quantities. Also, student created problems. Teach them to write their own word problems. It does involve some higher level thinking. Which one doesn't belong is another really great site. There's hundreds of these. It's just 4 quadrants with sometimes shapes or patterns. This one has numbers. And again, you just start to talk about which one doesn't belong. And again, anybody can answer this because maybe one of my kids who are, my novice learners when it comes to place value might say, well, this is 1-digit number and these are 2-digit numbers. Okay, great. So the 9 doesn't belong. Other kids in 3rd grade might start to say, well, these are squares. 3 times 3, 4 times 4, 5 times 5. So 43 doesn't belong. Or I'm sure you guys are thinking of other things. These are odd. 9, 25, and 43 are odd, so 16 doesn't belong. Or when I add the 2 digits together, 1 and 6, 4 and 3, 2 and 5, they equal 7. So 9 doesn't belong. So you can see how there's so many different answers and a lot of aha moments. And anyone can answer these problems. It's not just one size fits all. I just wanted to close it out with a video. This again, these are older kids, but I think it's important to see what kids look like when they're making sense of problems and not making sense of problems. And what we at the lower grades do when we give them those keyword strategies, thinking that we're helping them and giving them a scaffold, it's really just taking away their sense-making skills.
There are 125 sheep and 5 dogs in a flock. How old is the shepherd?
What? There are 125 sheep and 5 dogs in the flock. How old is a shepherd? I don't know how to solve this.
Why is that?
Because it doesn't talk about anything about the shepherd. Like, it doesn't say how old, like how long he's had them or anything. So like, it doesn't give me any hints about anything.
He's making sense.
Yeah.
Okay. Thank you very much. There are 125 sheep and 5 dogs in a flock. How old is the shepherd?
$120 old.
How do you know it's 120? Can you please write down here? Now, how do you know that the shepherd is 120 years old?
Because I subtracted 125 minus the 5 dogs in a flock.
Okay. Thank you very much. Thank you. Can you tell me, how did he know to divide?
Because it doesn't say the difference, or it doesn't say the sum, or the product, or something.
I see. Okay. Thank you very much.
So instead of like reading for understanding, she was really just looking for the keyword at the end, that last child, and just didn't say sum or product or altogether. So I'm gonna divide. And it actually was a reasonable answer. I mean, a shepherd could be 25, but here nor there. So, well, I am going to end because it is 4:15, but I'm staying on. So anyone who wants to stay on, ask any questions, make any comments, unmute yourself. I'd love to hear from you. If not, I really appreciate your time today. So many more people signed up for this. Sorry, I'm just going to unshare for this and didn't show up because teachers are real busy. And I get that. You guys have a lot to do and your day is really long. So I really appreciate you being here. So I'm going to stay on if you have any questions.
You're going to share this with us, you said?
I am.
Okay, thank you for that, because I couldn't take enough pictures of everything.
Yeah, absolutely.
Melanie, do you want to stop recording?